Find the domain and the range of the relation graph to the right. Well, to the right we have this blue jagged line with two filled in points at the end, and we're asked to find the domain and the range of the relation represented by this graph. Well, let's first consider the domain. And let's recall that the domain is the set of all possible inputs for this relation. Or another way of saying that is all possible x values for this relation. A useful way to consider which x values are part of the domain and which aren't is to consider a few. So let's consider the x value x equals minus 5. If we were to draw a dotted line above and below the value x equals minus 5, we'd see that this dotted line doesn't intersect this blue jagged line. Consequently, if we were to input x equals minus 5 into this relation, we wouldn't get any output because there's no intersection with this blue jagged line. So consequently, x equals minus 5 isn't a valid input because it doesn't yield a valid output or a valid y value. Consequently, we can see that x equals minus 5 isn't a part of the domain. Let's consider x equals minus 2. Well, if we were to draw a dotted line above and below the value x equals minus 2, we'd see that this green dotted line does intersect with this blue jagged line. If we were to input x equals minus 2 into this relation, we would get a y value of 3 as our output. Thus, we can see that x equals minus 2 is a valid input. We do get an output if we input it into the relation. Consequently, x equals minus 2 is going to be part of the domain. Let's consider one more. Let's consider x equals 4. But x equals 4, if we draw this dotted line above and below the value x equals 4, we see that just like x equals minus 5, we don't get any intersection with this blue jagged line. Consequently, if we were to input the x value x equals 4 into the relation, we wouldn't get any y value as an output. We wouldn't get any corresponding output. Consequently, x equals 4 isn't a valid input for this relation, and thus isn't part of the domain. Well, if we were to continue this process, we'd soon find that all x values less than x equals minus 4 wouldn't yield any valid y outputs, so they wouldn't be possible inputs for this relation. And all the x values, similarly all the x values greater than 3 wouldn't yield any y outputs, so they wouldn't be valid values either. But all the x values from x equals minus 4, including x equals minus 4, all the way to x equals 3, including x equals 3, if we were to draw a dotted line above or below those x values, we would always get an intersection with this blue curve. Consequently, these are valid inputs for this relation, and they are part of the domain. Another way to determine the domain would be to project this blue jagged line onto the x-axis as a line segment, and then consider which values that line segment represents. So for instance, if we were to project this blue line onto the x-axis, we'd get a line segment with a filled in dot at x equals minus 4, and another filled in point at x equals 3, and between those we'll use a highlighter here. We could draw a line. And this is a line segment. This line segment is essentially a projection of this blue jagged line onto the x-axis. And if we were to view the x-axis as a continual real number line, this line segment would correspond to all the valid inputs for this relation. Another way of saying this is this line segment is essentially the domain. If you were to write an expression for this line segment in numerical form, that expression would be minus 4 is less than or equal to x, which is less than or equal to 3. Well, this expression is the domain. It shows that any x value we choose between x equals minus 4 and x equals 3, including x equals minus 4 and x equals 3, if we were to substitute any of those x values into the relation, we would get a valid output value, so we'd get a valid y value. Whereas any x values less than x equals minus 4 or more than x equals minus 3, we wouldn't get valid y values. Consequently, this expression, which corresponds to this line segment, represents the domain for this relation. Okay, well, let's consider the range. Well, the range of this relation is the set of all possible outputs or another way of saying that is all possible y values for this relation. Let's consider a few. Let's consider y equals 4. At y equals 4, we could draw a dotted line to the left and the right of y equals 4. And we'd see that this dotted line doesn't intersect the blue jagged line here. Consequently, there's no x value we could input into this relation that would give us an output of y equals 4. So y equals 4 isn't a part of the range. Let's consider another y value. Let's consider y equals 1. Well, if we draw a dotted line to the left and right of y equals 1, we'd see that we get two intersections with this blue jagged line. We get one intersection at 0, 1, and another intersection at 2, 1. Remembering that when we say coordinates, we would say the x-coordinate first. Either way, we only need one intersection with the curve to show that it's a valid output. So because there is at least one intersection with this blue jagged line here, we can say that there exists at least one x value, which when input into the relation, gives us an output value of y equals 1. Consequently, y equals 1 is a part of the range. Let's consider one more. Let's consider y equals minus 3. Y equals minus 3, if we draw this dotted line, this dotted orange line to the left and the right, again, we see that there's no intersection with this blue jagged line. So there exists no x value we could input into the relation that would output the y value y equals minus 3. Consequently, y equals minus 3 is not a part of the range. If we continue doing this, we'd soon see that all the values between y equals 0 and y equals 3, including the values y equals 0 and y equals 3, are valid outputs because there are x values we could input into the equation which would yield y values between 0 and 3. However, the y values less than y equals 0 and greater than y equals 3 are not valid outputs because there are no x values we could input in this relation that would yield y values less than y equals 0 or greater than y equals 3. Again, another way we could think about this is to project this blue curve onto the y-axis. If we do that, we get a line segment which has a filled-in point at y equals 0 on the y-axis and a filled-in point at y equals 3 on the y-axis. And in between, we'd have a line that looks like this. And this line segment corresponds to the set of all possible output values for this equation, or another way of saying that is corresponds to the range. So how do we write this? Well, we write the range as 0 is less than or equal to y, which is less than or equal to 3. So this is the range of this relation. It also corresponds to this line segment if we were to consider the y-axis to be a number line of real values. And because it's the range, this specifies all the valid y values that could be output from this relation. And we're done.